Hello everybody, this is the Physics MC, and today we're going to talk about measurement and uncertainty. Physics MC, measurement and uncertainty. For IB Physics, let's get started. Alright, so let's talk about uncertainty. Imagine you had a 20-ton flying bison. Oh, whoa. Alright, so imagine you had a 20-ton flying bison from the Avatar world. There he is. Ah. Isn't he awesome? Okay. So, now, here's the situation. The Fire Nation is attacking your bison, and you want to find him some good armor to wear as protection, okay? So you need to make some measurements. So you want to get a nice suit there going on, like pretty Appa there, so you want to make a suit for him. Alright, got the picture? Good. So, what do you do? Well, you need to make some measurements to make an outfit for him, and then you don't have a ruler to measure him. So you have a problem. And you want to have enough material to build the suit. But having too much material can also be wasteful. So here we have it. You want to get enough material, you don't want to be wasteful, so you need to measure things as precisely as possible. So this is where uncertainty comes in. Uncertainty, think of it as kind of error. Any measurement that you make will have error with it, meaning that you'll be off by a certain amount. Well, we can gather our measurement tools, but since we don't have a measuring device, for this example, we're going to use cabbages for our standard base for measuring. We'll use cabbages. Why not? Hey, so there's our friendly Appa with a cabbage there, so we're going to measure him using cabbages. So let's get started. We can see that Appa is about 5 cabbages tall. However, if you look closely, notice that he's not exactly 5 cabbages tall. He's off by a little bit. Let's take a closer look. He's maybe like 4.5 cabbages tall, but you notice that we're not sure. He might be 4.6, 4.7. We could take a guess, but no matter what, we're going to be off by a little bit. There's uncertainty with this measurement. Okay? So we notice what? We're off by a little bit with our measurement. So we can be more specific, or in other words, we can include uncertainty to let people know how precise is our measurement. So how far is he off? 1 cabbage, 2 cabbage, or half a cabbage, quarter of a cabbage? We don't know, but we do know that we're off by a little bit, and he's about 4.5 cabbages tall. So moving on. So we have uncertainty. That's why we have uncertainty, because we don't know for sure. We can assume he's slightly less than 5 cabbages, but we know that measurement's a little bit off. There's error in that measurement. So we'll call him 4.5 cabbages tall. Alright? So it turns out the best that we can do is to have an uncertainty statement, meaning a statement that describes how much error do we have. So we'll call him 4.5 cabbages tall, plus or minus some value, some amount of cabbages off, okay? Well, since we measured, we know he's between 4 and 5 cabbages, okay? So his actual height, according to this, would be 4.5 cabbages plus or minus the smallest unit of measurement. In this case, it'd be half a cabbage. So right here, we could say he's 4.5 plus or minus 0.5 cabbages tall. And the reason this works is because, well, if you minus 0.5 cabbages from that 4.5, he'll be 4 cabbages tall. If you add it on, he'll be 5 cabbages tall, and thus, well, he's going to be in between 4 and 5 cabbages tall. And we can see that. We can obviously see that he is between 4 and 5 cabbages tall. So with that uncertainty, plus or minus half a cabbage, we know for sure he's within that range, okay? So why this works? Well, we know he's between 4 and 5 cabbages tall, so there's our error bar. Our error bar is between 4 and 5 cabbages tall. We know he's about 4.5, plus or minus half a cabbage. Okay, so you can jot this down if you want, but anyway, we can be 100% certain, we're 100% certain that he is between 4 and 5 cabbages tall. So we're certain. Uncertainty means that there's error. Our certainty says, hey, we know for sure if we include this error that we cover all the ranges of height that he could be. Alright, so The uncertainty in measurement accounts for all of this to happen. Yeah. Okay. So let's just get to something real. What? Are you saying that APPA's not real? Spoiler alert, yeah. Well, actually, I believe in APPA's, but, well, he is the last Airbender's bison, and we'll move on to something more practical. We'll use temperature. Why not? Let's measure for temperature. So use this Celsius scale here. What temperature does this Celsius scale say? Does it say 20 degrees? 21 degrees? Is it 20 plus or minus 1 degree? 20.0 plus or minus 0.5 degrees? Well, take a look. And the answer is, haha, I got you. It's negative 20 plus or minus 0.5 degrees. Yeah, so a little shit there is negative. It's negative because it's the 20 is up here and 30 is below it, so obviously it has to be a negative number because it's going down like that. So far so good, but here's the important thing. The answer is this. The reason for the plus 0.5 degrees is because that's uncertainty, and the reason for the 0.0 is because that this uncertainty has to agree with, the decimal place has to agree with this. So for example, you can't say 20 plus or minus 0.5 degrees. You have to say 20.0 plus or minus 0.5 degrees. The decimal has to be in the same spot. So talked about why it's negative. So why is that? Uncertainty cannot be more, you can't be more specific with your uncertainty than you were with the actual measurement. So if you measure to the closest 10th spot, your uncertainty has to be to the 10th spot. And remember, uncertainty is half of the smallest unit of measure, so obviously if your instrument measured to the closest centimeter, your uncertainty would be half or plus or minus half a centimeter that you would be able to say for sure that your measurement's in. So for example, you couldn't say that something was 100 meters plus or minus 0.0001 meters long because you measured this to the one spot and measured this uncertainty to the 10,000 spot. You'd have to actually measure this to the 10,000 spot to get to say this as well. So you could say this. You could say that something was 100.0000 plus or minus 0.0001 because they're both at the same decimal spot. In this case, the 0.1 or 0.001, your instrument must have measured to the 0.0002 in the instrument itself. So you can be off plus or minus half that. So that's your uncertainty. So now life is good, right? Well, we can make APPAsuit. Or can we? No, we only got APPAsite. That's not enough information to make a suit. You need other measurements. You need to know the total amount of material to make the armor. So we need to get measurements for APPA, different measurements. We basically want to order this material to make the suit. So we need square feet, or in this case, square cabbages, because we're measuring in cabbages. So we need a certain amount of material in square cabbages, kind of like this. How many square cabbages of material do we need? That kind of looks good. Although I don't like cabbage as much as other vegetables, but whatever. So we can imagine APPA as a cube. Why not? It makes the problem a lot simpler. Here's APPA. Hi, APPA. Yep. Okay. So how do we find the surface area of a cube? Basically, we want to get a suit for APPA to wear on the outside of his body. So we're just going to cover his body and imagine he's a cube. So the surface area of a cube is, well, there's 6 sides to a cube. 1, 2, 3, 4, 5, 6. And each side is base times height. So imagine his height times his height. So his height squared times 6 is the surface area of APPA. So basically you can break it apart. There's 6 different segments. All of them are a squared, or his height squared in this case. So we could assume APPA is a cube and make a suit from that. Order the material for the suit anyway. In square cabbages, that would be the measurement that we use. Alright, so we got 6a squared, a being his height. So APPA's height is 4.5 cabbages tall, but if you remember, there's uncertainty with that, so we might be off by a certain amount of square cabbages when we order the material. So he's plus 4.5 plus or minus half a cabbage. So we need to take that into consideration. So let's plug in the measurements. So 6a squared. So if you just plug in 4.5, you have 6 times 4.5 squared. It would be easy. It would be 121.5 square cabbages of material. But that plus or minus 0.5 is where it gets tricky. And once again, it would be 121.5 square cabbages material, but uncertainty says we're going to be off on that measurement. We're going to be a certain amount of, we could be as much as a certain amount off. And there's a way to calculate that. So the plus or minus part and uncertainty is the tricky part. So there's a couple rules to follow. All right, so rule number one, let's say that we want to add or subtract two values together. So this is a basic rule. Well, uncertainty always adds together. And the reason it always adds together is because the more measurements that you make, the more uncertain you become with your measurements. Let me explain this a second here. So, example, let's say we wanted to measure how tall two appas were. So we took two appas, stood up on top of each other, all right, circus act like that, and then we would just simply add 4.5 plus 4.5 to get 9 cabbages tall. But the uncertainty would be 0.5 and 0.5, so it's plus or minus a full cabbage. So two appas together would be 9 plus or minus 1 full cabbage. So uncertainty adds together. It always gets bigger because we might be off by this much in the first measurement for the first appa. We'd be off on that measurement again for the second appa. So then once again we have to add those into consideration. The same thing works for subtraction. If you're subtracting two values, you still add the uncertainty. You add the uncertainty because you're uncertain for both measurements. So let's say we wanted to measure Momo. Here's Momo here with the cabbage. He's about a cabbage tall, and we have Appa here, as we measured was 4.5 cabbages tall. So let's see, how much taller is Appa than Momo? So that's the question. How much taller is Appa than Momo? Well, we can subtract their heights to get that data, but we still add uncertainties, like I said. So when you subtract two values, Momo is 1 plus or minus 0.5 cabbages. His uncertainty is still 0.5 cabbages. Or same as Appa's because we used cabbages to measure their heights. So Momo is 1 plus or minus 0.5, and Appa is 4.5 plus or minus 0.5. So Appa is 4.5 minus 1, so he's 3.5 cabbages taller. But we still add the uncertainty. So he's 3 cabbages plus or minus 1 cabbage taller. So you still add uncertainty. Okay. So like once again, reiterate this fact. Uncertainty always grows. The more measurement that you have, uncertainty will get bigger and bigger. It's called propagation of error. If you're uncertain about one measurement and uncertain about another measurement, you'll be even more uncertain about both measurements put together. So they add together. So because you're uncertain about both measurements, and whenever you add or subtract multiple measurements, the more uncertain you become on the true value. Okay. Thus, uncertainty always grows. Okay. Now, uncertainty also grows when you multiply or divide different values. There we subtracted and added, but when you multiply or divide, it also grows, but there's a little bit of difference there. You can't just simply add the uncertainty together, like we said before. You have to add percentages. So let's do an example like this. Let's say you wanted to calculate how much times, like how many times Appa is, not the value, like 3.5 or 3.5 cabbages taller, but how many times bigger is Appa than Momo. When you multiply or divide uncertainty, you still add uncertainty, but now it's percent uncertainty. You have to add the percentage uncertainty. Let's say you're off by 10%, and you add the percentage onto that, those two values. So Appa versus Momo, Appa is 4.5 plus or minus half a cabbage, and Momo was 1 plus or minus half a cabbage. So how many times taller is Appa than Momo? Well, there you got a fight in there. In this corner, we have big old Appa, 4.5 cabbages. Here we have little Momo, 1 cabbage. So how many times bigger? Well, obviously it's 4.5. 4.5 is 4.5 larger than 1. But what about uncertainty? Well, like I said, we have to add the percent uncertainty. So to calculate percent uncertainty, we have to convert the uncertainty into a percentage. Okay? 4.5 plus or minus 0.5 cabbages is really 4.5 plus or minus a percentage of a cabbage, or a percentage. So your percentage of being uncertain. It's like an error percentage. What's the maximum percent from the total that we would be off? All right. So here's the math. So Appa's height was 4.5 cabbages tall, and we're uncertainty. We're about 0.5 cabbages off. We know that we might be as much as 0.5 cabbages off. Might be less than that, but it might be as much as that. All right. Well, to get a percentage, you just take the uncertainty, 0.5, divided by 4.5 times 100%. And so we could be plus or minus 11%. So we know his height is 4.5, but we could be off by 11%. That's percentage, okay? So we know that the maximum error that we'll have with APPA is 11%. But Momo is going to be different because he's a lot smaller. So when the smaller you get, the more uncertain you become with your measurements. So since Momo is a lot smaller, he's closer to the smallest unit of measurement. So that error is going to be a bigger percentage of his total height. So in other words, his percentage uncertainty will be bigger. All right, so Momo is 1 cabbage plus or minus half a cabbage. So we could be off by as much as 50% because 0.5 is 50% of 1. So Momo is, our measurement could be off by 50%. APPA, we could be off by 11%. So if we want to figure out how many times taller APPA was than Momo, it would be 4.5 divided by 1, which is 4.5, plus or minus 61%, because it was 11% for APPA and 50% for Momo. 11 plus 10 is, 11 plus 50 is 61%. So you always add percent uncertainties when you're multiplying or dividing. So the 2 rules, here we go. We'll come back to the 2 rules. What about squaring or cubing? Well, think about it. Squaring is just multiplying multiple times. Or cubing, you're multiplying things twice for squaring, or cubing, you're multiplying 3 times together. So it follows this multiplication rules. You add the percent uncertainties for every time that you multiply. So same goes for cubing. But there's a note that like if you wanted to square root it, then it would divide it in half. So that's one thing that you can actually decrease your uncertainty, but that'll be for a later video. So going back to APPA's armor, how many square cabbages would you need? Well, remember the equation, 6a squared would be 6 times a, which is 4.5 plus or minus 0.5 squared. So that squared means that you're multiplying the whole thing twice. So this is 4.5 plus or minus 4.5 times 4.5 plus or minus 0.5. That's this whole thing squared, and then multiply the whole thing by 6. Well, 4.5 plus or minus 11% times 4.5 plus or minus 11%, because remember 0.5 was 11% of this, is 20.25 plus or minus 22%. Okay, so let's finishing APPA. Get it? APPA. All right, anyway. So 20.25 plus or minus 22% times 6. Now you only multiply the 6 by the amount. 22% stays the same because 22% of this will still be 22% of the whole later. So your total still ends up being 125 or 121.5 cabbages, square cabbages, which is what we had before. But our percentage off, our uncertainty, we could be off as much as 22%. We could be 22% more or 22% less using cabbages to measure APPA. So that could be quite a bit. So that means the material that we need could be 22% off, less or more. So what to take away from this lesson? Here's the key things. So here's the rules to jot down for sure. Things that always remember. Uncertainty is something that shows how precise a measurement is. So the bigger uncertainty that you have, the more errors that you're going to have. All right, so that's rule number 1, or one thing to take away. Number 2, as the number of measurements is increased, meaning if you measure multiple things, or if you do mathematical operations to those things that we do with multiplying the things and subtracting, the uncertainty will go up. It's called propagation of error. So the more things you do with the math, the certainty always grows. You always add uncertainty. All right, so and then the last 2 things here, if you're adding or subtracting values, remember when we added the 2 APPAs together, or we subtracted Momo's height from APPA's height, you always add absolute uncertainty. Absolute uncertainty was just a value itself. We add the 0.5 and the 0.5 together to get 1 cabbage. And then and the last step is if you're multiplying or dividing values, you always add percent uncertainty. So you have to convert to a percentage first and then add that together. So anyway, this has been the Physics MC. Happy measuring. Yip yip, APPA. Yip yip. Bye bye now.